Here we are discussing about Kubernetes concept, very, very important. I said already Kubernetes will be used to maintain containerized applications or containers, we can say. And maintaining a containers means container orchestration, already I said. Here we can say the Kubernetes will be used to maintain the containerized applications. Maintaining the containers means container orchestration. Kubernetes is a container orchestration tool, or something we can say. Container orchestration means performing the following actions on the containers. This Kubernetes will be used to maintain containers only. Till now, till previous classes, what we discussed about containers, it is going to maintain containers. Like performing the following actions on the container. What actions we can perform here means deploying the containers automatically, scaling, already said, that can be scale up or scale down. Scaling, like increasing the containers, and the scaling can be done in two ways. Scale up. Scale up means increasing the containers. Increasing the containers or application instances, we can say. Application instances. And also, if not required, if when we should scale up the application, means when there is demand or when there is traffic, for the application, more traffic coming to the more requests, in which to handle that you should scale up. Scale up means increasing the application content application instances. Or else we can also do like scale down. Means when there is no more traffic, then you can decrease that increased application. Decreasing the containers or application instances. Like this, scaling is very, very important here. Scaling and scaling nothing but scaling will be happen to perform to give high performance. Scalability, both are same. Scaling and scalability. To give high performance. When there is more traffic, to give high performance for the end user, you want to scale up. When there is low traffic, okay, we don't want that number of instance more, then you can scale down. Like scaling we can do, monitoring we can do, and also desired state. Already I said the number of required containers or application instances I want like 2 or 10, for example. See here. If you want more number of instances, like for example, I want 10 instances to be run, like this. Right? These are all containers. Assume like some 1 to 10 containers I want, for example. Like one. Assume like 1, 2. Till I want 10 containers. My desired state is 10 containers or instances I want to run in my application. For example, if any one container For example, in this, if any one container is stopped, assume like my desired containers to be run in my infrastructure is 10. For example, while running for any reason, hardware reason, whatever it may be, one container or out of 10 containers, one or two containers stopped. In that case, what is the desired state here? This desired state means how many containers to be run? 10. My requirement is 10. Here, as an input, as a DevOps engineer, I'm going to run the desired state as 10 containers. I want to run 10 containers like this in this Kubernetes cluster. In this infrastructure Kubernetes cluster, I want to run 10 containers. That input we are going to give to Kubernetes. How to give? We'll see later. In which the Kubernetes is going to be maintained that desired state only. Okay, whether 10 containers are running or not, it will check. Okay, if it runs, no issue. If 10 containers not running, if any one container stop or two containers stop or 5 containers stop, if it is checking that the desired state is 10 but is not running 10 containers, then what it will do? Immediately, it will achieve that desired state. Achieve that desired state means if among 10 containers, one container stop, then what it will do? If, for example, one container stop, this container stopped here. Container stopped here. Then what it will do means immediately the desired state is 9. Sorry, the running state is 9, but the desired state is 10. One container stopped here, assume that. Then Kubernetes immediately identify that okay, the desired state is 10, but it is running only 9 containers. Then immediately what that Kubernetes will do means will achieve that desired state. Okay, if 9 containers only running, 10 not running, immediately 10th container it will start. Like that, to achieve the desired state, by achieving the desired state, what I can say means it is going to be high availability or no downtime. Means among 10 containers, one container not running means some requests will going to that particular container only. That requests are going to, for example, 10 containers are there, 10 containers are running. For all 10 containers, some requests are coming here. Here, for example, some requests coming here, some requests are coming to here, some requests will coming here from the end users to the application. These containers means from web application, containerized. If this container not runs, what happened? For these users, they cannot access the website. That is known as a downtime. That's why if desired state is not equals to running state, what happens? There will be downtime for some particular users about your application. That's what to achieve that higher availability. To achieve this higher availability without downtime, okay, what Kubernetes will do means, okay, it will achieve desired state. If desired state is 10 containers, if there is not run 10, immediately it will start or it will achieve the 10 containers. Then there is no downtime, there is no like stopping instances for the end user in which it will provide higher availability or no downtime. Higher availability, no doubt how it will provide by achieving the desired state. And also scalability, I said that just now I said here, and restore and backup it will. Like this to perform these actions. Okay, container orchestration tool we want in the infrastructure. Among that, one of the important container orchestration tool is Kubernetes. Beside that, Docker Swarm or OpenShift. These are also important things. These are also some usage things only, but majorly industry using Kubernetes. If you learn Kubernetes, if you want to learn others, also you can learn easily. First, you want to learn Kubernetes here. Kubernetes only going to use maximum. Or another important thing is OpenShift also. And third option, Docker Swarm. The first option is Kubernetes. Like this, to orchestrate the containers or to maintain the container, maintaining or orchestration, both are same. Meaning, Kubernetes will be used to maintain the containerized application. That's why I said the point. Maintaining the containers means container orchestration only. In that case, we can say that Kubernetes is a containerized or container orchestration tool. What is container orchestration? By performing all these actions, we can say it as container orchestration. Means whatever the Docker containers we learned till now, those containers we are going to maintain automatically. Means deployment, scaling, monitoring, higher availability, disaster recovery, maintain desired state, everything we are going to achieve by automatic tool known as Kubernetes. To achieve this manual, it is not easy. It is not easy and not going to be done by the people manually. If you want to achieve this manually, it is not possible. That's why to achieve these actions automatically, we are going to use an orchestration tool known as Kubernetes. This you should understand first. What is the use of Kubernetes? They'll ask the first entry question. What is the use of Kubernetes here? What is Kubernetes first? It is an orchestration tool. What is orchestration? We can say Kubernetes or container orchestration tool. We can say immediately. What is container orchestration? Container orchestration, maintaining the container. Maintaining means they will ask you. Maintaining means deployment, scaling, monitoring. These are all points. If you say that's enough. First thing, first introduction points. They will ask you these points initially. What is Kubernetes? Okay, what is the use of Kubernetes? Where it is going to be used? Kubernetes is a container orchestration tool. What is container orchestration? Maintaining the containers. How we can maintain the containers like deployment, scaling, monitoring, higher availability, scale. What is the high performance disaster? To achieve this in the infrastructure level, we are going to install one tool known as Kubernetes. First, okay. Then after, I said already here, where Kubernetes is going to be installed means in infrastructure. Okay. How we are going to use this? What is the architecture of Kubernetes first? Before going to this diagram, directly I gave this diagram to make you understand. In the infrastructure level, to maintain the containers on different machines or systems, we are going to use Kubernetes, in which whatever the machines we are going to maintain under containers, these are all we are combined under Kubernetes software tool as a cluster. Cluster means group. Simply you can say that what is cluster? Grouping the systems as one unit is known as cluster. Grouping the systems as one unit is known as cluster. These are all points first you need to understand theory. Then only practically we can do easily, fastly. Without knowing all those things, you can't do practical session. That's the first I'm trying to explain you practical, explain the theory part. Very, very important. Okay, now first before going to this diagram, okay, directly I gave this diagram, but first architecture you want to understand here. Okay, the point I said already, what is Kubernetes? Now, to learn about Kubernetes, you need to understand about what is the architecture of Kubernetes. The next thing is architecture. Kubernetes architecture. Very, very important. These are all things. Interview question. Try to understand. Kubernetes architecture. See here. Majorly in Kubernetes architecture, three things we are going to use. In Kubernetes, mainly we can use three nodes. We can say three nodes. Not only nodes, we can use majorly, we can say that we can use the following things. You can say like those are master. Majorly we can use following nodes. We can say nodes. Nodes nothing but systems. Nodes or systems I can say. One is master node. Worker node. workstation node. See here. In Kubernetes architecture, majorly three things we are going to nodes. Nodes nothing but systems. What are in the diagram we showed one system, two systems, nothing but one computer machine. We are technically calling here it as a node. Node nothing but systems or computers, I can say. For your understanding purpose. Nodes or systems or computers. Okay, that I'm calling it as majorly we can use following nodes or systems. In Kubernetes architecture, this is first thing is master node, or we can say that control plane of control plane. And next thing is worker node. Next is workstation. These three things you want to understand first. In Kubernetes architecture, majorly we are going to use three systems, so three nodes, so three computers. One is master node. We can go control plane, worker node, workstation. In which overall Kubernetes will be controlled by master node in the name itself, master node. Overall Kubernetes will be controlled by master node. Under that master node, worker nodes we are going to use. Worker nodes means in which the containers are going to be deployed. I said already, Kubernetes will be used to deploy the containers. I said where the containers we are going to deploy in the systems. Those systems we are calling it as worker nodes. Not only one worker node, multiple worker, but majorly I'm saying one worker node we require, one master node we require, and to maintain or to give input for master node, we are going to use workstation node. Okay, that will see that. All these three things or three nodes we are going to use to maintain or to orchestrate the containers in Kubernetes architecture. Master node means majorly complete container orchestration will be done with master node. Means it is the head of the cluster. I said already, cluster. The nodes what I'm showing here will be under this cluster only. Means in one node, in one system, master node we can maintain. The remaining systems we can maintain as worker nodes. That means I'll show you with another diagram. See here. For example, it is assumed like it is a infrastructure. Complete setup we are going to maintain under one infrastructure. This infrastructure can be a AWS cloud or infrastructure. This infrastructure can be AWS or Azure or local or we could say that on premises. On premises means in your organization. On premises, we can say that organization, local organization. On premises means local organization. This is nothing but the infrastructure. In this infrastructure, generally, infrastructure means collection of some machines that can be, if it is on premises means your systems. If it is Azure means VMs we can call. If it is AWS means we can call it as EC2 machines. Whatever it may be, it is known as one infrastructure setup. In this infrastructure, some nodes nothing but systems. In Kubernetes architecture, we can call it as nodes simply. Okay, here assume like for example, these are all known as nodes. Okay, in which in these nodes, okay, nodes nothing but some systems. In these systems, we are going to maintain three things. One is master node. One system I want to maintain as master node. The remaining one system I want to maintain as workstation node. The remaining systems I want to maintain as worker node. In this, for example, this I want to maintain as master node. Worker node, worker node, worker node. Okay, like this. Nodes we should create first. Nodes means systems we should create in the infrastructure. Like in this setup, okay, number of things, number of things we have, number of nodes we have here. But master node, not only one master node we can take multiple master nodes also. But in this, depends on the requirement, first I'm taking with one master node here. Not only one master node we can create, depends on the requirement, multiple master nodes also we can take. But all this one master node is going to be maintained some worker nodes. Understood here? Like this. Okay, first in this first you want to create some systems like EC2 machine or VM or in on premises. By using any VMware, you can create some machines. In this machine, you want to install Kubernetes first of all. In the master node, you want to install Kubernetes. In the master node, you want to install Kubernetes. To this master node, all the remaining systems you should join to this master node. Then this becomes one worker node. Now, whatever the systems we are joining to the master node, okay, all these systems will be grouped as one unit. First, you want to take one machine, in that you want to install Kubernetes. To this machine, the nodes or the systems what we are going to add to this master node, you want to add all the systems to the master node. Then all the systems which are added to the master node will comes under one group or one unit, and that group or unit we can call it as cluster. Okay, all the units, all the systems that we are going to bind or combine to the worker, combine to the master node. Means first you want to create one machine as master node. Master node nothing but installing the Kubernetes. Now to this master node, the remaining systems, if you add any system that you added to this master node, okay, will be under one group or unit. Okay, these all systems will be under control of master node now. Okay, this complete group that are added to the master node, or all the systems that are combined to the master node, we can call it as one group or unit. This group or unit we can call it as cluster. This group or unit we can call it as cluster. This is known as cluster. Cluster means group or unit, simply for your understanding purpose. Okay, that means if you install any Kubernetes into one machine, that becomes master node, and the system what you added to that master node will be under one group or unit. All these nodes that includes master and worker nodes as a single unit or group known as cluster. This is known as Kubernetes cluster. Kubernetes cluster. But in this, two things only I'm showing here. I'm showing here two things. One is master node control plane, which will control complete cluster. The master node will be used to control complete cluster. Cluster means group of systems. And worker nodes, nothing but that added to the master node will be under the cluster, I said. But where the workstation node we have? Workstation node means, what is workstation node means? Workstation node can be within the cluster or can be outside of the cluster also. Okay, now I'm taking workstation node here. This I'm going to take as workstation. It is my workstation. It is also one system only. It is also one system, but this I'm going to take as workstation. This is workstation. Workstation node nothing but one system only. But from this only we are going to give input. What is the use of workstation node? As a DevOps engineer, we are going to give some input to the master node. Master node will control all the worker nodes. But to give the input to the master node, from where we should give? We should give from another machine known as workstation node. Means from here, from workstation node, we are going to give input to the master node. We are going to give input to the master node. Means from workstation node, input to master. Okay, from workstation node, we are giving input to master node, but workstation node can be out of cluster. It is not going to be inside the cluster. It is another machine, another system. Okay, who are giving the input as a DevOps engineer? We are going to give the input. As a DevOps engineer, we are giving input to master node from the workstation. From workstation node, we are giving input to the master node. In which master node means from here we are giving to the input to master node will control complete cluster. How, what it is going to be, what master node is going to be do, same thing. What I said, deployment, scaling, monitoring, everything what I'm saying here, okay, everything what I'm saying here will be done by master node only. How? By giving a input to master node by the DevOps engineer. Okay, how we are going to give input means we can manifest file we have. As a DevOps engineer, we are giving input here. How we are giving input means with the help of one manifest file. Manifest file we are giving. We are giving input to the master node from workstation node with the help of